today we are actually, I just want to take you through a couple of questions that are normally posed in assignments, in exams. At least you should have at least an understanding of how to actually treat some uh, questions as they come along. So I have chose a previous question paper. However, some of the questions will just be arbitrarily so that I should just explain the concept behind, tackling the questions. Okay. So uh, I think it's very important to also note that the questions that I have chosen for today includes the entire coursework. However, it is very important that you go through all the exercises that are provided in the study guide, all of them. And my first advice would be to say, go through the exercises without even looking at the solutions at the back. Just go through the exercises. Once you are done with those exercises, you can actually mark yourself looking at the solutions. And obviously, when you mark yourself, you will pick up where you are actually lacking, and you can go and do them again to rectify maybe the process or the incorrect process that you have taken. Okay, so I will just start with just a few questions. Most of the questions that are posed are multiple choice. This nowadays we know that they are all found online, so they are not provided to students. However, I believe that the solutions would be provided to students for students to actually see the steps for future reference. Okay. Please do pose some questions if you have some questions as I go through this couple of questions. Okay. The first question that I will just pose here, it says solve the following equation. We can see that this is an equation because of the sign there. And when we look at this equation, we realize that there is a variable called x there. So it is very important that one solves this step by step, So the first thing that we start with is just to break brackets. So when we break brackets, we just multiply this 3 into whatever that is in the bracket. So you will have 3x on the left-hand side plus 3 multiplied by 1 will be 3. Okay. And this can be written as is plus 4. So this is equals to 5. You bring it down because it's a constant. The minus sign, you bring it down. So if you take a negative 3 multiplied by x, it will give you negative 3x. Okay. And then negative 3 multiplied by negative 2. So negative multiplied by negative gives you a positive value. So 3 multiplied by 2 becomes a 6. So it becomes plus 6 in that regard. And once you have done this, all the constants should go to the right-hand side, and the items that have the variable x should come to the left-hand side. Okay. So our next step then will be 3x. If we bring this 3x, negative 3x onto the left-hand side, then it becomes a positive 3x. Okay. And then this will be equals to, we still have our 5 here, we have our plus 6 here on the right-hand side, and then we need to bring the 3 and the 4 onto the right-hand side. So you will have minus 3, minus 4 as they go to the left-hand side. Okay. So in this regard, that means we have here, when we add these two terms, we have 6 6x. So 6x will be equals to 5 plus 6 gives you an 11, and 11 minus 3 and 7, 4. These two, if you have negative 3 minus 4, this will give you minus 7. Okay. So you have minus 7 there, so it means on the right hand side you will end up only with a 4. And then on the left hand side you will have 6x. So to move the 6 away so that you are remained only with x on the left hand side, we just divide both sides by 6. Okay. When we divide both sides by 6, it means we have x equals to 4 divided by 6. However, this can actually be further simplified. If you can see, 4 is just a multiple of 2. You can use 2 on the numerator and also on the denominator. So you divide this by 2, the numerator by 2, and also the denominator by 2. Okay. This upper part will give you 2, and then the denominator will give you a 3. So 4 over 6 is just the same as having 2 over 3. So 2 over 3 is basically your answer for this particular question. So once you have solved it like that, you can then go and look at what the option is. So we can see that this is option 4. Option 4 is the correct answer in this regard. Okay. The second question is also posed here. It says that you should also solve an equation. This equation is actually given here. It's given by 30x divided by 9 plus 2, which is equals to 5x. Okay, so we can see we have the similar situation as previous, as question 1. However, there is a fraction here that we can actually observe. Okay, so it's important that we get rid of the fraction first before proceeding. Once we have worked out the fraction, that's when we can actually work out the x value. Okay, so to get rid of this fraction, I think it's important to just take this 9 and multiply all throughout by 9. Each term you just multiply it by 9. So you will have 9 multiplied by 30x divided by 9. That will be for the first term, plus 9 multiplied by 2, which is for the second term. And then that is equals to 9 multiplied by 5x. So what you do on the left-hand side, you do on the right-hand side. Yeah. So we can see here that this 9 is just going to cancel out with that 9, and we will only be left with 30x. Okay. And the 9 multiplied by 2 will give us an 18. Okay. On the right-hand side here, if we take this 9 and we multiply it by 5, that should give you 45. Yeah. So you will have 45x here. Yeah. However, we want these x values to actually be on the same side. So we will just take the x values to the left-hand side and the constant values to the right-hand side. So you will have here 30x minus 45x to be equals to 80. When we work out this, because we have the same variable here, if you say 30 minus 45, then you will be remaining there with 30 minus 45 will give you a Okay, let me just correct, because we have taken this 18 to the right hand side, we have a negative there. Okay, it was positive, so when it comes to the right hand side, it is negative. So here we will have negative 15x, yeah, to be equals to minus 18. Okay, so in this regard, we want to only remain with x on the left hand side, and the constant, the values should be on the right hand side. So we'll just divide here by negative 15 on both sides. Okay. So we see that we will have x equals to 18 divided by 15, because the negative here will cancel out with that negative. Okay. However, we can still further simplify this, because we can see that this particular value 18 and 15, there is a value that can get into 18 and also into 15, and it should be actually the same value. When I look at this, I see that if we divide the numerator here with a 3, and we also divide the denominator with a 3, then at the top we will have 6. 18 divided by 3 will give you a 6. Okay. And then at the bottom, 15 divided by 3 will give you a 5. So this can be simplified to 6 over 5. Then we can go to our options and say 6 over 5, positive 6 over 5 is our option. Okay. So we can take that as our option. So let's move on then to other questions, such as the third question, whereby you are actually requested this is the same question that I've posed. Let's find another different question. This question is actually relating to having some expressions that have some powers and or even exponents, and you have to actually simplify. So this is an expression, because it doesn't have an equation. It's just one value that doesn't actually involve any equations. Okay, so we need to actually simplify this by looking at what square roots, what is the square root of each and every item that is inside of the square root. Okay, so we can start by finding the square root of 36. All right, so we can start with 36. So if we simplify this, then we realize that the square root of 36 is nothing but equals to 6. So you can just write down your 6 here. And here, okay, let me just elaborate this further to say, when you have variables that has the powers like that, please note that it's the same as having a variable to the power of half. The square root is the same as having a variable to the power of half. So if you have the square root of x, is the same as having x to the power of half. So here you could have had 36 x to the power of 4, y to the power of 16, all of this to the power of half. And we can actually multiply this half inside. That will mean that you have 36 to the power of half multiplied by x to the power of 4 multiplied by half multiplied by y to the power of 16 multiplied by half. Okay. So it basically means that here the 36 to the power of half is the square root of 36, which is just 6. And here you can see that 2 gets twice into 4. So the answer for that is just going to be x to the power of 2, because this gets twice in here. Okay, and then for this one here, 2 gets into 16 4 times. So you'll just have y to the power of, 2 gets into 16 8 times. So you will just have y to the power of 8. Okay, so this will basically give you the final answer. Okay, so it basically means that 6x squared to the power of 6x squared y to the power of 8 is your final answer that you can actually then take in this particular option. Okay. And I'm just going to follow up with other question. I just have something here. Please give me a minute or two. We can continue with other questions, especially with regards to variable. You could be having other kind of variables such as this. In this case, the a that you see in there is a variable. Now, you have an expression that is given here. You have a into 2a squared minus a minus 4, close bracket, minus 2a, open bracket, a plus 3, close bracket, minus 1. So they say here, simplify the following expression as far as possible. So I think it's important just to try to simplify it as much as you can. And you will see how I actually go about it. I will ensure that the higher powers of this particular variable a are the first ones that start on the left-hand side, going to the lower powers. For instance, you can see here on option 1, you have a higher power and then followed by the second highest and then the lowest. Okay, so we make sure that when we simplify this expression, the higher powers are on the left-hand side. So we'll start by breaking the bracket. So for the first one here, a multiplied by 2a squared, we have 2a to the power of, when you multiply, let me take 2a, okay, let me just simplify it further so that at least you understand. So if you take a and you multiply it with 2a squared, then you will also have a multiplied by a minus 4 multiplied by a. On the right hand side here, you will have a negative because there is a negative there. So it will be minus 2a multiplied by a. And then here on the second term, you will also have a negative. You have negative 2a multiplied by 3. And the last term, because it's not in bracket, it will just be negative 1. Okay, so you look at this same variable. So when you multiply, you should note that you have to add the powers. So it means that for this expression here, we will have 2a to the power of 2 plus 1 here, which is 3. Okay, so you'll have 2a to the power of 3. The second one, you'll have minus a multiplied by a is the same. You just add the powers here. So you'll have a to the power of 2. Okay, a to the power of 2. The next one is just 4 multiplied by a. that will just be 4a. Okay, then the next one will be negative 2a multiplied by a. That will be 2 to the power of a squared. Okay, because there are two of them to the power of 1 to the power of 1. Okay, and then the last term that has a variable there is just 2 multiplied by 3, and that will give you a 6. And you just write the a down, then you will have minus 1. So in this case, we just then collect the like terms. We see that there are no any other a to the power of 3. So we're just gonna write 2a to the power of 3 as is. However, there are two of where you have a to the power of 2. Okay, so in this case, we will have negative a squared minus 2a squared. So negative a squared minus 2a squared will give us minus 3a squared. Okay, and then we also have this term here where a appears on those two terms. So we have negative 4a and minus 6a. So in this case, because we have negative, then we will end up with minus 10a. And then the last term is just negative 1 there. Okay, so in this case, we can actually have a look to see which option corresponds to that, and we realize that option number 3 is the one that corresponds to this answer of ours. So option number 3 will be the option that we will actually be taking. Okay. Any question in that regard? Yeah. So without any questions, I will just go on. If you have some questions, you are more than welcome to just raise your hand or even post, say it on the chat. Okay, and then I'll come and have a look at them, at those questions. Okay. So another question could be that such a question that needs you to actually simplify the expression as far as possible. It seems like it's the same question, this one. Let me choose another different question. Yeah. So our question number 5 basically say simplify the following as far as possible. So in this case, we have some fractions here. We have some fraction. The first fraction says 5 over 6 divided by 3 over 6, and then you have a multiplication there, multiplied by 3 over 15. Okay, so the first important aspect to consider is to ensure that this division, because this is a fraction, this division, it is changed to multiplication. Okay. So when we see such a situation, we want to ensure that at least we deal with multiplication all across, because it simplifies things. Okay, so we will write our 5 over 6 as is, and to change this division to a multiplication, it basically means that this term 3 over 6 will swap. The denominator will become a numerator, and the numerator will become the denominator. So we will have here multiplied by 6 over 3. This is one of the properties when you are actually simplifying fractions that has some division sign. Okay, and then the last time, which is just 3 over 15 will remain as is. Okay, so we can see here that 6 cancels out with 6, 3 cancels out with 3, and we are left here with 5 divided by 15. However, we can simplify this further by just looking at the value that gets into this both denominator and numerator, which is the same. And I pick up 5. So if you use 5 here, we'll get ones on the numerator, and also it will get 3 times into the 15 that we see. So you will end up with 1 over 3, because 15 divided by 5 is 3. So it will be 1 over 3. So we can choose our option there to be the second one. Okay, the second option. There are some further examples where we instead of multiplication and division, we make use of the addition and subtraction in the fraction. Okay. So it says here, simplify the following as far as possible. So what you need to simplify is 5 over 6 minus 3 over 4 plus 7 over 24. Okay, so what is very important in this case, we want the denominators, all these denominators to be the same. Okay, we first realize that these denominators we can use some values to actually make them the same, so that the simplification, we have a simple expression that we can deal with. Okay, so the first one is if you take a 6 and you multiply it with, we realize that if you take a 6 and you multiply it with a 4 over 4, because 4 over 4 is the same as 1, then we can do this. We can just multiply the denominator and the numerator with the same value there. And then the second term as well, we can take 3 over 4 and multiply it with 6 over 6, so that they become 24. And the last term there, we will just have 7 over 24. So we realize that for the first term here, we will have 20 divided by 24. And then second term there, you will have 18 divided by 24. And then the last one will be 7 divided by 24. Okay. So when they are the same like this, it's simple. We can just add and subtract the numerator. So we will just have the denominator of 24 because they are the same. And then at the top, we will take 20 minus 18 plus 7. Okay. So we realize that 20 minus 18 plus 7 actually works out to 9 divided by 24. Okay, 9 divided by 24. And we also note that there's a factor. We can simplify this further by dividing the numerator with a 3 and also the denominator with a 3. Okay, so when we divide the numerator with a 3, we realize that we will have a 3, and 24 divided by 3 will actually give us 8 16, 24, it will give us 8. Okay, so this will be our final solution to this particular expression. So we then take option number 4 to be our correct option for this particular problem. Please do say when you have some questions. You can have another problem whereby you actually have to simplify again. In this case, it is the addition that has some multiplication, fractions with addition and multiplication. So in this case, we then start with the multiplication first. You remember the BODMAS principle. So bracket of multiplication, division, addition and subtraction we do it last. So we start first with the multiplication. So when we consider the multiplication here, we'll just write the 3 over 4 as is, and then this will be a plus. Okay? We just take 1 multiplied by 5, the numerator will multiply them as they are. Okay, so we will have a 5 as a numerator, and then 2 multiplied by 4 will give us an 8. Okay, so the next step is that we should make the denominator the same. Okay, so we will just make the denominator the same, assuming that we want them to be similar to the higher value, which is 8. So we will have 3 divided by 4 multiplied by 2 divided by 2 plus 5 over 8. Okay, so here we will have 6 divided by 8 plus 5 divided by 8. Because the denominator on both terms are the same, all we're just going to do now is to add we will just add the numerators. We'll have an 8 here because they are the same, and then add the numerator 6 plus 5. And then our final answer here becomes 11 divided by 8. We can now simplify this further because we can see that there's no value that will actually get into both of them, which is a lower value. Okay. So in this case, our option will be option number 2. Right. Yeah. So we can then have another question whereby we deal with the lowest common multiple figures or variables, whatever that will be given to you. Here they say, determine the lowest common multiple of the following expression. So this expression basically is 16a squared bc multiplied by 8a 8a. So let me just verify this. This expression. Indeed, it's 6a squared bc and 8a bc and also 12ab to the power of 3. Okay, so all we want to do here is to find the lowest common multiple of all these terms. So it is very important that for each and every term that is given here, we break it down into some lowest common multiple. Okay, so for the first term here, we realize I'm just going to write the first term here, a 6a squared bc. So this here, we can write it down as 3 multiplied by 2. These are the lowest terms so that you can find. And then the second term where you have a variable, you will have there A multiplied by A, that will give us that, and then we'll have multiplied by B multiplied by C. Okay, so that is the first breakdown of the first term, and then for the second term, we'll have A, 8A, B, C, and then when we break it down, we realize that we can write it as 2 multiplied by 2 will give us a 4, and then 4 multiplied by 2 will give us an 8. So we can write it as 2 multiplied by 2 multiplied by 2, which will give us an 8. And then we can write also the variables that follows, which is multiplied by A, multiplied by B, and also multiplied by C. Okay, and we move on then to the third term, where we have 12A, B to the power of 3. For that one, we then realize that if we take 2 multiply by 2, it will give us a 4. In order for us to get a 12, then we multiply this by 3. 2 multiplied by 2 multiplied by 3 gives us a 12. Okay, so once we have that part, then we come with the variables. We have multiplied by A and also multiplied by B, multiplied by B, multiplied by 3 B's that you are multiplying there. Okay, so in this case, then we just have to have a look at the first place, second place, third place as they go on to see if we take the lowest common multiple of all of these terms, what are they going to be? So in this case, we will have the lowest common multiple as for the first term, we will definitely have a 2, and the second term we will have a term of 2 as well, and the lowest common multiple as well on the third term will also be a 2, and on the fourth term we will have a lowest common multiple of 3. Okay, and we can actually have a look at the A. So we will have a lowest common multiple of A and another A there, and looking at the B's, there are about 3 B's. So the lowest common multiple will have B multiplied by B multiplied by B. And then we can also see that the last letter there is C. So we also include a C there. So it basically means that 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 multiplied by 3 will give us a 24. Okay, so for the second term of variable, we will have A squared. For the third term, we will have B to the power of 3. And then for the last term, we will have only C there. Okay, so our option in this case in terms of a lowest multiple common will be 24 A squared B to the power of 3 and C. Okay, so that will be our lowest common multiple. Okay, then we can move on to questions that are relating to some maybe linear equations. So this question says that the length of a rectangle is 3 less than twice the width. Okay, so I think that this relates to having to write this particular expression in letters. It says, suppose that the width is x centimeters, give an expression in x for the length of the rectangle in centimeters. Okay, for the length of the rectangle in centimeters. So in this case, we just have to simplify this sentence here and write it down according to the way they are expressing. So they say the length of the rectangle is 3 centimeters less. 3 centimeters less than twice the width. So we can just say let W be the width. Okay, and if W is our width there, or we can, because they are using X here, I will suggest that you also make use of X in this case. So they've also said, suppose the width is X centimeters. So we don't even have to write this let. We can just write an expression the way it is needed. Okay, so our expression is going to be given by twice the width. So twice the width will be expressed with 2x. And then they said the length of the rectangle is less, so it will be less than 3 centimeters. Okay, so the length of the rectangle is 3 centimeters less. So meaning that the twice the width is actually greater than 3, meaning that we're going to take twice the width, and subtract the 3 centimeters out of it. Okay, so it basically means that our option is just going to be equals to option number 3. Okay. If you have some questions, let me know. Question number 10 says you are given the expression x squared multiplied by x to the power of 3 divided by x to the power of 5. Now here it's important to understand how we manipulate the powers, okay, when the base is the same. Okay, so consider this having the same base. So when something is at the bottom, we can write this expression as 2 to the power of x multiplied by x to the power of 2 multiplied by x to the power of 3. Okay, multiply by, when the denominator is given as x to the power of 5, when it goes to the numerator, we write it as x to the power of -5. Okay, so remember that when the bases are the same, in this case we have x also out, then we just add the powers when we do a multiplication. So in this case we will have x to the power of 2 plus 3 minus, because this is a minus sign, minus 5. Okay, so we'll have x plus 2 plus 3 minus 5, which basically means that you will end up with 5 minus 5. Okay, so this is x to the power of 0. Okay, so any number that is to the power of 0, even if it can be a variable, we know that it is actually equals to 1. Okay, so that's how you basically calculate that. Someone else could have said, okay, I can see the numerator already, it's there. All I can do is to add the power. So you can have x to the power of 5, because it's 2 plus 3, which gives you a 5, divided by x to the power of 5. Now, because these are the same, the numerator and the denominator are the same, then it basically means that we will end up with a 1 there. X to the power of 5 into x to the power of 5 is actually equals to 1. Okay, so there are numerous ways on which you can actually solve this problem. However, your option in this case would actually be given by option number 4. Okay. The next question is a question about some areas and perimeters of a certain round. Okay, so here it says a garden is laid out so that it consists of a rectangle. So we can see a rectangle there with a semicircle at each of the shorter ends. So here we have a semicircle. So the side on the right hand side is a semicircle, and we also have another semicircle that you can see here. And they actually give us the distance of the semicircle, which you can refer to as a diameter. Okay. The garden contains a square fish pond and 6 circular plant areas. Okay. So we have a square that is given there of 2 meters each length, and also the semicircles of 1 meter each given. So they also tells us here that each planting area has a diameter of 1 meter. Okay, so it means we have 1 meter for these small circles inside. The remainder of the garden is the lawn. Okay, calculate the perimeter of the garden rounded to 1 decimal digit. Okay, so the perimeter, when you calculate it, the only thing that we are looking for is just to add the side of the garden. Okay, so we have to bear in mind that the garden contains a square fish pond and some 6 circular planting area. So we just have to actually write down the perimeter. So I'm just going to write down the sides of that we are actually looking at. We just add in the side in this case. Okay, so it basically means that we have this length, which is given by 10 meter. You can call it a width of the garden. So we will take that twice. So it basically means even this side here, from here to here, you still have your 10 meters. So you'll have 10 meters multiplied by 2. Okay, and then plus we have the semicircle here with the diameter of 8 meters. So it basically means that we can take half the circle, half 2 of the circle, multiplied by 2 of our pi 8. Okay, multiplied by 8. So that is just the area, that is just the sides of all of this particular. So this part here is half the circle. I don't know how to actually represent it, but it's this part here, which is half the circle up until here. It's half the circle, and another one on the left-hand side here, it's also half the circle. Okay, so we just take half of pi 8 multiplied by 2. Okay, in this regard, it basically means that we'll have a 20. You can see that the 2 will cancel out with the 2, and we'll just add 8 pi there. Okay, so in your calculators, you have a sign of pi. You know pi to be 2.7 something. You can just make use of that. If you are using a Casio, if you press shift and multiply sign just next to a dot at the bottom, you will see a pi on top. Shift multiply by 10 to the power of x. That's where you will find a pi. And the value of pi, it's given as, I'm thinking of the value of E. E is the one that is 2.7, 1 something, and so on. Pi is equals to 3.141 I think, with a 9, and then it continues like that. Okay, so if we take 8 multiplied by that pi, and also adding a 20, so we'll have here 8 pi to be something like 25 point. If they say we should round off to only 1 decimal point, it will be 25.1. So adding these two will have 45.1. Okay, this will be given in meters because all the sides are actually given in meters. So our option in this regard is given by option number 45.1. Okay. Is there any question? So the parameter is just adding the sides, the outer side of the entire ground. Okay, so we have the 10 at the top, 10 meters at the bottom, and half the circle, we know that it's half multiplied by 8 multiplied by pi. Okay, so if we take 2 of these, then we write it as given as that. Okay. So we can take another problem which also refers to the same question that we have here. However, in this case, they say you should calculate the area of the lawn rounded to 1 decimal digit. Okay. Now, with the area of the lawn, we know that the area is given by the width multiplied by the length. Okay. In this case, we will have to actually map out all the terms that are actually necessary to actually come up with the area. Okay, so in this case, the area of the lawn then will be, if we look at this, we want to take the length times the width, the length times the width. Our length times width is actually given by 10 multiplied by 8. Okay, so we have that 10 multiplied by 8. However, it will mean that the area out of that will only be the inner part. Okay, now we want also the semicircle part, both of them to actually be considered and included. And furthermore, we should also consider the other terms. Okay. Now, when we come to the area of the semicircle part, then we're just going to add the pi. We're just going to add pi multiply by, then we come to this part here. This part will give us a 2, 2 multiplied by 2 to give us a 4 squared. So here we will have 4 squared, and then we will also consider including the half of the circle times 2. Okay. So this part here is for the semicircle part. This is the entire area. However, we need to actually subtract this area here that we find here. So if we subtract this part here, it basically means that we are subtracting 2 multiplied by 2, the area, the length times the width of the square that is given to us there. Okay, and also if we subtract as well the 6 the 6 circles, semicircles here, subtract all these circles that you see here, then we will be subtracting the diameter it's 1 here, and then the radius then will be given by half. Okay, so we will have here pi multiplied by 0.5, which is a half to the power of 2, and then multiply by these 6 circles that we find inside. Okay, so what have we actually done here? We have taken this area here, this whole area, okay? We have added this dot, this semicircles on both sides here that you see, okay? And then after doing that, we are subtracting this square that you see of 2 meter and these 6 circles. These 6 circles, we are just subtracting them so that we have an area of the garden. Okay, so we are just subtracting all these 6. That's what we have done here. Okay, so when we work out this part here, we see that this will cancel out with that. You will have 80 plus 4 squared is 16 pi. 16 pi. Okay. And then minus on the right hand side here, you will have 4 plus 0 0.5 squared will give you 0.25 multiplied by 6. That will give you 1.5 pi. 1.5 pi. Okay. So we see that we will have 80 minus 4 will give us 76, and then 16 minus 1.5 will give us 14.5 pi. Can use your calculator. In this case, 76 plus 14.5 multiplied by the pi, then you will end up with 121.6 when you round it off to 1 decimal point. This will be given by meter square. Okay, so when we go to our options here, then we realize that option number, our option number is option number 1. Okay. Right. So moving on to other questions, we can still refer to the same sketch and then calculate what is known as the volume in this case. So they say refer to the same sketch that you have seen above. However, now calculate the volume of the fish pond in liters if it is 1.5 meter deep. At least they are actually giving us that the ponds in this case, they are the fish pond is actually given as 1.5 meter. It is 1.5 meter deep. Let's remind ourselves what is the pond. The garden contains a square fish pond. So this square is basically a fish pond. Okay. However, this square, it is a square that goes down 1 point. It has, let me see. It has it is 1.5 meter deep, meaning that will be the length of it. So you have 1.5 meter deep. Okay. I don't know how to draw it, but okay. So going down like that and up, this area here will be given by 1.5, and then that part, that length, there will be given by only 2 meter, meaning that that should be shorter. But that's what I'm just trying to actually illustrate. Okay, so we can come here and actually write down the formula for the volume. We know that the volume is given by the length multiplied by the width multiplied by the height. Okay, in this case, your length is given by 2 meter, the width is given by 2 meter, and also the height is given by 1.5 meter. So we just take these values 2 multiplied by 2 multiplied by 1.5. Yeah. When you take that, then this will basically give you 4 multiplied by 1.5. That will give you 6 meters cube. So this is a meter, this is a meter, this is a meter. So you're going to have 6 meter cube. However, when we look at the solutions here, they tell us that everything is given in liters instead of meters. So we should know that 1 meter cube is actually equals to 1,000 liters. Okay. So 1 meter cube is equals to 1,000 liters. It basically means that we need to convert our volume into liters by taking 6 multiplied by 1,000 liters. And then that will give us 1,000 liters, 6,000 liters. So we note that our option is option number 1 there. Okay. Right. So some questions then can be given, such as a question where you just have to make sense out of the formula. It says that if C is equals to 2 of 2 multiplied by length plus width, make W the subject of the formula. So making W the subject of the formula is just bringing the W on the left-hand side. It should be alone on the left-hand side and ensuring that there are some variables and values on the right-hand side. So how do we do that? You have L plus W. Okay, so the first thing, because this, we have a multiplication of the bracket and also of 2 there. Okay, so you need to get rid of 2. So we will divide both sides, first thing, both sides by 2. Divide both sides by 2. So this 2 will cancel out with that 2. Okay. So it means you're going to have C divided by 2 equals to L plus W. And then when you bring L on the left-hand side, you're going to only remain with W. So you can write C minus C divided by 2 minus L is equals to W. Okay. So this can also be written as W equals to C divided by 2 minus L. Okay. So you can see that the W is given just by C over 2 minus L. Uh, this, just to put it in a simple term, you can still write it as they actually are looking for here, because here we see that option number 4 is actually having a plus. Okay, so to ensure that we choose the correct option, so this one is definitely out. This one is also definitely out. To ensure that we choose the correct option, we make the 2 the lowest common denominator. So we will have a C here. If we take these 2 into 1, then gives us a 2 multiplied by L, then we will have minus 2L. Okay. So this particular formula is the formula that we see for option 2. Okay. So we can choose the correct option. So the 3 are actually out. Okay. Furthermore, if we go to question number 15 now, let's have a look at question number 15. It says, question number 15 says that a company manufactures soccer balls. The company's daily fixed cost, that is the rental, phone, stationery, etc., are 18,000 rand. Okay. One soccer ball costs 500 rand to manufacture, and it is sold for 800 rand. How much profit does the company make per day if 100 soccer balls are produced and sold per day? Okay. So I think it's very important that maybe the first thing that you should consider here is to consider that you have the cost. Cost is the amount that has that you have used to actually manufacture the soccer ball. Okay. And then you also have the selling price, which is the amount that you are selling that particular product with, which is 800,000 in this case. And you also are looking for the profit, and the profit will be basically the selling price minus the cost. Okay. So we want to consider the total of that, you know. So if we first look at the total cost in this case, the total cost will be given by, you see here the cost, we have the company's daily fixed cost, which is 18,000. We have 18,000, that is the fixed cost, and we want to take this 18,000 and actually add it to the cost that comes from manufacturing the soccer balls. Okay, so we have about 500 here, 500, and then this 500 is multiplied by 100 of the soccer balls. Okay, 100. Yeah. So we can actually work out that first. So when we work out this, if we take 500 and we multiply it by 100, that should give us 50,000. Okay, so we have 18,000 plus 50,000. So that will give us 68,000. So the total cost is actually 68,000. Then we move on to the selling price. The selling price will be the selling price of the soccer. So selling price is actually given by, we have 800 rand multiply by 100 soccers, then it will give us the total selling price of these balls, then it will be 80,000. Okay. Once you have determined that, now the next step is actually to determine the profit in this case. So our profit will be equals to the selling price. Let me just represent selling price with SP minus the total cost, TC. Okay, meaning that this is just TC and this is SP. Okay, so in this case, we'll take our 80,000 minus the total cost, which is 68,000. Okay, so we realize that 80 minus 12 gives us minus 68 gives us 12. So we'll end up with 12,000 as our profit in this case. Okay. So once we have determined that, we can actually say that the correct option is option number 1. Okay. So we have answered the question of how much profit does the company make per day if 100 soccer balls are produced and sold per day. Okay. Right. Our next question then moves over to some straight line equations. So we know that the straight line equation has some properties, that one has to know of. One of the properties is that a slope can be given as well. And in this case, when I read this, it says calculate the slope of the straight line graph which passes through the point -1 and -2, and also through the point 3 and 4. Okay. One can actually have a graphical representation of this particular point. Okay, so we know that when we deal with graphs, we need to have a Cartesian plane. Okay, so a Cartesian plane says that your horizontal is your x, and then your vertical is your y. Okay, and here we have 1, 2, 3, 4. I will just make this to 4 points, 3, 4. And then when you go up as well, you have 4 points. So that will be 1, 2, 3, 4. When you go to the left, you also have 4 points. -1, -2, -3, -4. When you go down with the y-axis, you also have 4 points. So you have -1, then -2, -3, -4. Okay. So this we call x1. On the right hand side, we have y1. These are the coordinates. And here we have x2 and y2. Okay. So on the x-axis, we can actually have the plots. So we have our first point, which is at -1 and -2. -1 on the x-axis, which is this part here going to the left-hand side, and also at -2. So this point here that correspond to 1, -1, and also correspond to y with which is -2. That will be the first point. Then our second point will be 3 and 4. 3 and 4 can be found in the first quadrant there. This is the third quadrant. This is the second quadrant. This is the fourth quadrant. And this is the first quadrant. Okay. So 3 and 4, when x is equals to 3 and also and 4 can be found there. That point is found there. So it basically means that this linear line goes straight like this that we are looking for. So what are we looking for? We want to know what is the change in y over the x values. So what is the change in y? Meaning that y2 minus y1 over this point here, which is x2 minus x1. So the slope, which I'll just represent with an m, is just equals to, you can call it a slope. Some people represent it with a, some with m, and so on. Yeah. So the slope in your equation is given by mx plus c. Okay. So this is what we are looking for. We say that it is equals to the change in y, meaning x2 minus y2 minus y1 divided by x2 minus x1. Okay. So we can substitute these values here because we have them there. We have 4 minus -2 there. So we have this point here, which is 4 y2, and then y1 is equals to -2, divided by 3 minus 1. Okay. So we just need to calculate that. When we calculate this, it will give us 4 plus 2 divided by 3 plus 1. And this is 6 divided by 4. We can simplify this further because 6 and 4, we can use 2. You can see that 2 does get in there, and also it does get in there. Okay, so we will have 3 divided by 2 as our slope. So you can go to your options and look whether you have 3 divided by 2, which is option number 2. That will be your correct option. You can also have some questions relating to some added text, value added text. Question number 17. It says here that question number 17 says that a dealer sells a certain washing machine for an amount of 2,410 rand, excluding value-added tax. If we assume that this value-added tax is 14%, what will the washing machine cost, including VAT? We know currently, I think it's around 15%. Okay, so we need to actually determine the tax, the value-added tax of 14% on this amount of 2,410 rand. How much is it? Okay. So how do we add? What will the washing machine cost if we include VAT on the 2,410 rand that we're going to use to buy the machine? Okay. First thing, we know that VAT is given by 14%. 14% can be written as 14 divided by 100. Okay. Which basically means that we need to take this 14 divided by 100 and add it to the cost of the machine that you are having, that you will be buying. So the VAT percentage is given there. The VAT amount will be equal to 14 divided by 100 multiplied by 2,410 rand. Okay? So when you arrive at that point, you can just use your calculator. In this case, if you have 2,410 and you divide it by 100, that will give you 24.1. So you'll have 14 multiplied by 24.1. However, if you take these two and multiply them, 14 and 24.1, then you'll end up with 337 rand 40 cent. Okay. So the VAT, the value added tax amount, is 337.40 cent. Okay. So we need to then take this amount and add it to the cost. So you take the cost of the machine and add the VAT amount. That will give you, the cost is given as 2,410 rand plus the VAT amount is equals to 337 rand 40 cent. If we add these two, that will give you 2,747.40. Okay, so we can then go back to our options and look which option is actually giving us the right answer. There we see that it is option number 3. So that is when you have added the value added tax onto the cost that you're spending. Right. Okay, so another question says, suppose you need 5 eggs to bake 2 cakes. How many eggs will you need to bake 14 cakes? So I think this question actually relates to some uses of proportions when you have to find out the number the number of x that you have to actually make use of. Okay, so if we use some proportions, x needed in this case to bake 14 cakes, we can write that down, that we have 14 cakes, and we should also consider that you need 5x to bake 2 cakes, meaning that 14 you can divide it by 2 cakes, to form one proportion. Okay. And then when you take that and you multiply it with 5x, so we have 14 cakes over 2 cakes that are produced basically. So when you have 5x, we realize that with 5x over 1, we can actually determine. So you have the first proportion, which is 14 over 2, and then the second proportion, which is 5 over 1. Okay. So once you have determined this, then it becomes easy to see how many x you can basically use, how many eggs you can use to actually bake 14 cakes. So it's just your 14 cakes divided by this given 2 cakes, multiplied by the 5x over 1 egg to actually determine the entire lot of eggs. Okay. So in this case, you'll end up with 14 multiplied by 5, so that should give us about 70. So we'll have 70 divided by 2, and 70 divided by 2 will give us 35. So it's a cross multiplication that we have actually determined here. Okay. I think the correct step that we should actually consider here is to let x be the number of x we are looking for. Okay, and once you have let x to be the number of x you are looking for, then it basically means that you will have an equation that says that so that says that the 2 by 8 on the left hand side, you will have a proportion that is given as x over 5. Okay, so you're looking for that number, which is x, and then on the right hand side, you'll have 14x over 2. Okay, so here you have 2 cakes, so you need 5x to bake 2 cakes. How many eggs will you need to bake 14 eggs? So how many eggs is represented by x? Okay, and then the 14 is the one that is given on the right hand side. So x should actually produce 14 cakes. X should produce 14 eggs. And and x takes over the 5x, it's given as a proportion on the left-hand side here, and then 14 cakes over 2 cakes that are produced by 5 cakes is given as a proportion on the right-hand side. So it becomes easier to now do the cross multiplication in this case by saying that x will be equals to just 2 multiplied by x and 5 multiplied by 14. And then you can take your x to be equals to 5 multiplied by 14 divided by 2, okay, which is similar to the answer that we have produced of 35x. Okay, so we can see then our option in this case is given by option number 3. Okay. Moving on to the next question. So I see that I've actually went overboard in terms of time. However, if all is good, I can just continue until I am done with this explanation of the questions so that you can find in the question paper, in some question papers. Okay. Right. Okay. I can see some thumbs up. I'm just going to continue with this, explaining it. So we have question number 19, and question number 19 is related to the simple interest calculations. It's when you take the interest into consideration. Okay. So it says here, Joseph invested 36,000 at a simple interest rate of 6% per year. Sometimes they use per annum. How much will he have after 6 years? 6 years and 5 months. First thing first is to know the formula. We know that we make use of S to represent the future value. You can make use of S or future value, and we know that S is equals to P, which stands for the present value, and we have the interest part, which is called 1, the simple interest part. It's called 1 plus the rate, the interest rate per year multiplied by the term. Okay. Or you can just represent it as a future value multiplied by 1 plus I multiplied by n. So I don't know which one you normally make use of. I will just stick with the first one because it's a simple one to use. Okay. So given this formula, it's very important that we write down first the terms. So here, Joseph invests. Immediately when it says that, it basically means that that will be your present value. That is what he starts with at the first term. It is also very important at some point to actually understand the timeline. Okay, right, we'll get there. So P is actually equals to 36,000. We need to write that down. Yeah. And then we also need to write down what is the interest and what is the term. So in this case, the interest R is given by 6% per year. So 6% written, we can write it down as 6 divided by 100. That is how we can write it. Okay. And then our term is equals to, they say for how much will he have, how much will he have after 6 years and 5 months. So 6 years and 5 months, we can write it here, 6 years, 5 months. It means it's 6 and 5 over 12. Okay, because we have 12 12 months in a year, it basically means that the component, the fractional component of this term will be represented by 5 divided by 12. It means 5 months in 12 months within a year. So it's 6 years and 5 months in 12 years, in 12 months. Okay. So by so doing, this can be simplified to a fraction that we can write in terms of months. We just take our 12 and multiply it with 6. You see that when you take a 12 and multiply it with 6, you'll have 72. So you can take that 72 and add it to the 5. That will give you 77 months over 12 months. Okay. So once you have determined all of this, you can just plug in this into your formula now. For our, okay, I'm gonna use the first one. So F will be equals to 36,000 multiplied by 1 plus, and then the rate is equals to 6 divided by 100 multiplied by 77 divided by 12. So simplifying this, you can just make use of a calculator. 0.06 is the interest. You can multiply it with 77 divided by 12. You will see that you will have 36,000 into 1 plus this whole term here will give you 0.385. 0.385. Then when you add them, you'll have 36,000 multiplied by 1.385. 1.385. Okay. So taking 1.385 and multiplying it with 36,000, that will give you an amount of 49,860 rand. Okay. So the future value after 6 years and 5 months will be 49,860. Then you can go and choose it there. So it's given as option number 2. Option number 2. We have other questions relating to simple interest. You should just bear in mind that with a simple interest here, you can be given the future value and then be requested to find the present value, meaning that you just make P the subject of the formula. If P is the subject of the formula, then it's just going to be P equals to S divided by 1 plus RT, if you make it the subject of the formula. Or you can be given PSR and they say you should find the term. Okay, so any of those terms can actually, any of the items in the formula can actually be found by just manipulating and making the subject of the formula, what is needed, the subject of the formula. Here they say that Susan invests 45,000 at a simple interest rate of 6%. So I'm just going to write down the terms that are needed to actually complete this problem. Okay, so Susan invests, I will just call this the present value for Susan is equals to 45,000, and a simple interest rate per year for Susan is actually given as 6% divided by 100. I'm just gonna call that. And 2 years later, she invests another 20,000. So 2 years later, Susan invests another 20,000. Let me write that. This is the first, and then the second, Susan, but she invested 20,000 at the same interest rate. So still the same interest rate, 1 and 2. What is the total amount that Susan will have after another 3 years? Okay, so it's very important with the timeline. I think it makes proper sense. Here is today, and today Susan puts in an amount of 45,000. I'm just gonna write 45,000 here at an interest of 6%. Okay, so this interest will yield after maybe we have the first year, we have the second year, the 2 years. So what we are looking for is S at this point. Okay. However, Susan decided to add another amount, to invest another amount. 2 years later, she invests another amount, meaning that at this point, she actually invests 20,000. Okay, and at the same interest rate. And the question says, what is the total amount that Susan will have after another 3 years? Meaning after 1, 2, 3, meaning that she would have invested 45,000 for 5 years. However, 20,000 for 3 years. So all of these amounts that you are looking for should actually come here at this point here, which is point number 5. We don't consider that because that is exactly what they are looking for. They are looking for S at the end of 5 years. Okay. So how do we write that? We have S to be equals to the first amount that we invested is 45,000, and then we multiply this with the interest component of it, which is 6 divided by 100 multiplied by 5 years. So this 45, we want to know how much will it be until the end. So it's just gonna be 5 years divided by 1. It's just 5 years. Okay, plus the 20,000 that she adds on there, and the interest for this 20,000 is just going to be from this point to from the second year to the 5th year. So it's just from this point to that point. So it's just going to be the same rate of 6%, 6 divided by 100 multiplied by, in this case, 3 years, because it's 1, 2, 3 years. Okay. So we can calculate these two terms here. Okay, we realize that when we take 1 plus 6 multiplied by 5 divided by 100, that will give you 1.3. So you will have 45,000 multiplied by 1.3 plus 20,000 multiplied by 1.8 So here we have 1 plus 6 multiplied by 3 divided by 100. It's 1.18. Just a minute. Let me confirm this. So this is 1.18. And then when you calculate this, taking your 45,000, multiplying it by 1.3, that will give you 58,500 plus 20,000 multiplied by 1.18, that will give you 23,600, 3,600. Okay, then when you add this, that is 0, 0, 1, 2, that will give you 82,100. Okay, so 82,100 is the amount that will come out of Susan's investment, the way she has done it. Okay, so it is very important that sometimes you have compound interest. So this question that follows says, determine at what interest rate per year an amount will be doubled in 10 years' time if the interest is compounded monthly. So this is what we mean by the compound interest. So with the compound interest, we still have our future value, which is equals to the present value. Then the part that changes is the part of the interest component. So here you will have, we can represent this as an interest per annum divided by M. This M is the compounding period. Okay, so the number of compounding periods that we find in a year, we represent it with M. So this is equals to our TM. The term is still given as the number of years, and then the M in this case, it's your compounding period. This basically means that N that we are seeing up there, it's still the same as TM. Just the compounding periods that we find in the year. Okay, so and also the interest can just be represented by this fraction Jn divided by M there. Okay. So firstly, as before, we need to extract the necessary information that we would be using in order for us to actually determine the interest. So determine at what interest rate per year an amount will be doubled in 10 years' time if the interest is compounded monthly. Okay, so what do they really mean? They mean that if you have a present value and you invest it today, then in 10 years' time, it will be 2 times what you have invested today. One can just then assume maybe 100 rand. Assume that you invest 100 rand today. What will it be in 10 years' time? It will be 200 rand. So it basically means this will be the present value, and then that present value, the S will be twice the present value. So S will be twice the present value. Okay. So that's what we basically mean by that. Because when you take your 100, if P is equals to 100, it basically means that S will be equals 2 times P. That's basically what it means. Okay. So when we go down to our formulation, we note that here the compounding period is equals to 12. So M is equals to 12 months. So we need to write that down. And then our term is actually 10 years. 10 years. That is our term. So we note those two. And the S that we need to make use of should actually be given as, if we look at this formula here, the S should be given by 2P. So meaning that we're going to have our formula being given as 2P equals to P into 1 plus Jm divided by M to the power of Tm. However, what is it that we are actually looking for? Here they say we should actually determine the interest rate per annum, per year. What interest rate per year are we looking for here? So this is what we are looking for. So in that regard, we want to make this part here the subject of the formula. Okay. If we make this the subject of the formula, we're going to divide both sides by P. We divide here by P and here by P. It basically means that we will have this cancelling out with that, and then on the left hand side here, P will cancel out with that P. So we don't have any P in the formula anymore. And we also want to get rid of this term at the top. So to do that, we apply our natural log on both sides. We will have natural log of 2, which is this 2 here, equals to the natural log of 1 plus Jm divided by M, okay, to the power of Tm. So we know that when we have a log, the powers can actually be brought here in front. Okay. So it means we have ln of 2 equals to the power which is Tm, and ln of 1 plus Jm divided by M. Okay. So we have that formula. We can then substitute the necessary terms that are needed in this case. We have a Tm, so if we get rid of the Tm here, we will have, in this case, this will be equals to ln of 2, and then 12 multiplied by 10 will be given here, and also ln of 1 plus Jm divided by M. Okay. So we can divide both sides by 120. We'll have ln of 2 divided by 120 to be equals to the ln of the interest part, which is Jm divided by M. Okay. Once we have done this, we then realize that the Jm is still within the bracket. To remove it in brackets, we apply the exponents on both sides. Applying the exponents of ln of 20 divided by 120 And also on the right-hand side, if we apply an exponent here, then that exponent will cancel out with the log. You'll only be remaining with 1 plus Jm divided by m. Okay. So our m is equals to 12. We can just substitute it. So 12 is given there. We are left with j. Therefore, our j will be given as our Jm will be given as is 12. The one when you bring it to the left-hand side will be a negative. So you'll have e to the power of ln of 20 divided by 120 minus 1. Okay, that is when you make Jm the subject of the formula. Okay, so when we calculate this, you can just calculate it by saying 12, and then on your calculator, multiply, open bracket. The exponent is found just on top of ln. So shift ln, then at the top you put in the fraction. At the top you put ln of 20, and then the denominator for that fraction becomes 120, and you just move to the right hand side with the arrow to put -1. Okay, and then close the bracket. Then you will find a value of 0. And you find the value of 0.0. Here you'll have a 0.0695. Okay. And once you have determined that, to change this into a percentage, you just multiply this by 100%, and that will give you a value of 6.95%. Okay. And that will be your final value, and you can basically go and choose the option that you are looking for. So it's very important that you go through all the steps that are necessary to actually determine the answer in this case. Yeah. So the next question then says you should also determine some of the compounding interest rate. Let me just pose it. Determine the amount of interest that will be earned if 8,000 is invested for 13 months at an interest rate of 13% per year, compounded half yearly. So as we have done with this one, I think it's very important that we do the same with this. So here, our present value is that 8,000 that we are talking about that will be invested. Our term is 30 months. So we just write 30 divided by 12, meaning that our M is just equals to 12. Okay. The interest rate in this case will be given by, let me just correct this. Our M is given by 12. Yes. However, we have the interest being given, the interest is compounded half yearly. Okay, so we need to change our M to half yearly, meaning that we have only 2 terms on which the interest will be paid per year. So our interest in this case will be given as 13%. You can represent this 13% by 0.13 divided by the, 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 the compounding period on which the interest will be paid, it's only 2 in this case. Okay. So we need to plug this into a formula. S equals to P multiplied by 1 GM divided by M to the power of TM. Okay. So if we plug it into the formula, very important, 8,000, you write it as is 1 plus our J, it becomes 0.13 divided by 2. So in this case, our M is equals to 2. And then for the term here at the top, we need to take our 2 and which is the amount on which the interest will be paid, the compounding period. It's basically 2 times. It will be paid 2 times. And then we also have to multiply this with the 30 divided by 12. Okay. That's how we have to write it. So when you calculate what is in the bracket, you'll have 8,000 into what's in the bracket will give you 1.065. Here, you can see this gets in here 6 times 6 into 30 will give you 5. So you'll have 5 at the top there. By calculating this, you'll end up with 10,960.69. Okay. So what are we looking for? The question was saying that you should determine the interest. So by determining the interest, you will take the future value as minus the present value. In this case, you have 10,960.69 minus 8,000. That will give you 2,960.69. That will be your final answer, and the options relating to that will be given by option number 1. Okay. So there are times on which the investment amount it's given, and maybe you want to know the payments, or you are taking a loan of a certain amount and you want to know the payments that you need to actually return on a monthly basis. And such situations, sometimes we call them annuities. Okay? So question number 23 talks about an annuity. Sarah wants to save an amount of 100,000 over 2 years for a deposit on a townhouse. She wants to make weekly payments into an account which offers 8% yearly interest rate, compounded weekly. In this case, you have to determine the size of her weekly payments that she has to do. Okay. So it talks about the future annuity that one has to actually make use of here. So the formula for that is actually given by the future annuity, it's given by the payments, which is represented by S, by payments are represented by R, and then the interest component of it will be given by I plus 1, or just 1 plus I to the power of n minus 1 divided by I. Okay. So the formula for that is given here. So it's very important that we extract all the information that are needed. I is equals to, we can write this down, 0.08, and the term weeks in a year, we only have how many weeks? 52 weeks. So our compounding weekly will be given by 52 weeks. And then what other terms do we have in this case? We have to look at other terms. She wants to make weekly payments into account which offers 8% yearly interest rate compounded weekly. 2 years, the time on which should be making those deposits. Okay, so we have the T, we have determined the T, we also have the S, which is given as 100,000. Yeah, that's an amount that she wants to actually save. Okay, so it means here we need to determine the value of R. R is the one that is in this case. So we can make R the subject of the formula by saying R is equals to S divided by 1 plus the interest term to the power of n minus 1, all of this divided by I. Okay. So, and make the substitution. It means that the numerator is just going to be 100,000. The denominator is going to be 1 plus the I is 0.08, 0.08 divided by 52, which is the compounding period to the power of 52 multiplied by 2, which is 2 years, okay, and then minus 1. All of this we divide it by 0.08 divided by 52. Okay. If you hit your calculators here, you should get the denominator, because it's the interest part, as 112.688 if you round it off to 3 decimal points. Then the final answer here will give you an answer of 887 rand 40 cents. Okay, 887.40 cents will basically yield the third term. Okay, so one can actually ask the question of how does one know what kind of a formula to actually make use of in order to determine such. So here we see that Sarah wants to save an amount of 100,000. It's what she puts in the bank account every week in order to arrive at amount that is equal to 100,000. So in your timeline, you can even make your timeline. You will have the first year and second year. So this first year contains 52 weeks, and this one also contains 52 weeks. However, in these weeks, from today, the first week, she will be depositing R amount. So this amount will be equal. They will just be R amount, which is the amount that you are looking for. And then the S is the amount that will be yielded at the end of the term, which is just under 100,000 given as 100,000 with an interest of 8%. So the 8% needs to, my internet was gone for some seconds there. Okay. So immediately when there is such a situation, that means you can actually make use of this future annuity formula, and it's the one that is actually given here. So this amount is given to you already, so you can make use of it. However, there are some points whereby you are given the present value. In a sense where there is a present value, that's when you actually make use of the present annuity formula. Okay, let's have a look at the next question. The next question says that in 1997, Justin bought a three-bedroom house for 480,000. He paid a deposit of 150,000 and secured a loan for the outstanding amount. It looks like, because there is a loan here, it looks like this will be a present annuity formula that will be used. The yearly interest rate on the loan was 24 months, compounded monthly, and the term was 20 years. Determine the outstanding amount at the end of 10 years if Justin had done all monthly payments in full and the interest rate stayed fixed on 24% per year for the whole period. Okay, so the first thing that I note here is that there is a loan that Justin actually secured. So he bought a house. That house cost 480,000. 180, and he deposited 150,000. So minus 150,000. And the difference between these two is what we call the loan. The outstanding amount is what we call the loan. So the difference here is 330,000. So this is the loan that Justin actually secured, and that will be your P. This has been done for a period. Okay, for the interest it's given here as 24 0.24 divided by 12, because he has been making monthly payments. Okay, and here we also note that the term, which we can just represent as n, the n, our n is actually equals to 12 months multiplied by 20 years. 12 multiplied by 20 years. And we know that 12 multiplied by 20 years, that will give us 240 months. 240 months. Okay. So I think we have all the terms that are needed. In this case, we are actually looking for an R. And the formula that we'll be making use of is called P multiplied by R. The interest component is given by 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n. So in this case, we just have to make R the subject of the formula, because that's exactly what we are looking for. So R will be equals to P divided by 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n. So we just plug in all the values that are needed here. Yeah, so we'll have 240 minus y divided by 0.24 over 12 multiplied by 1 plus 0.24 over 12 to the power of 240. Yeah, this whole numerator term, you can just put it into your calculator. You'll have 330,000 divided by 49.5685. I think it's 855. Okay. So when you do the entire calculation, you see that you have the final value as 6,657 point, rounding it off to 2 decimal point 45 cents. Okay, so it basically means that the question was basically saying that we should calculate, determine the outstanding amount at the end of the 10th year if Justin has done all the monthly payments. Now, at this point, we actually need to take this amount, which is 6,657, and multiply it now back to see what is the present value, which will actually be the outstanding amount after 10 years. Okay, so the P in this case with the R and the interest part, that is given as 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n, is the one that we're going to make use of. So because we have determined the R value here, we are just going to plug it in here. Okay, so in that case, you will have 6,657.45, and the interest part will be your 1 plus 0.24 divided by 12 to the power of apologies for that. I'll just be back. Just give me a second. Apologies for that. I had a call coming in. I needed to take that. Okay. So we complete this by just substituting. In this case, we only have the outstanding amount after 10 years. So we only have that 10 years being substituted there. Similarly, with the denominator, we'll have 0.24 over 12 multiplied by 1 plus 0.24 over 12 to the power of 12 multiplied by 10, which is just 120. Yeah. So this term here, you'll have 6,657.45 into 45, the interest component, you'll have 45.355389. Okay. So you can just round it off to 2 decimal places, and then you'll have 301,951 and 8 cents. 951 and 8 cents. Okay, so this amount is the amount that will be outstanding after 10 years once once the interest has been paid in full. Okay. So that will be the amount that will be outstanding after 10 years of Justin once the interest has been paid in full. So when we come here, we can basically see that that relates to option number 2. I have the last question. Only have the last question that I will just go through. It's also relating to some annuities. Let's have a look at this last question. So we just refer to the information that is given above there from Justin. Yeah. So furthermore, it says, suppose Justin had paid 8,000 per month into the loan account from the start. How long will it take to pay off the loan if the interest rate stayed the same? So we have seen that the interest rate was 24% per annum, compounded monthly. So the question still relates to us having to find the term, which is N in this case. So we have P equals to R multiplied by the interest component, which is 1 plus I to the power of N. This N is the one that we will be looking for. Okay. Divided by I into 1 plus I to the power of N. Okay. So if we are looking for the N, in this case, we have to make a plan of actually writing the N as the subject of the formula. Okay. So what sometimes I suggest is it's important just to substitute all the values first and then work out making N the subject of the formula. So above, we have seen our P was actually given as 330,000. We can substitute that. And then our R, it's now different if he paid 8,000 per month. So the payments, it's now given as 8,000. We just substitute that 8,000. The interest in this case, it's still fixed. It's 1 plus 0.24 divided by 12 to the power of N minus 1. The same with the numerator. We have 0.24 over 12 into 1. Let's just take this up. Plus 0.24 divided by 12 to the power of N, which we are looking for. Okay, so we can work out this or simplify it. What is in the bracket here? 0.24 divided by 12. You will see that it will give you 0.02. Okay. So on the left-hand side, you can have 330,000 divided by 8,000. And then in the brackets there, you can have 1.02 to the power of N minus 1 divided by, this is 0.02 multiplied by 1.02 to the power of N. Okay. So we then can actually multiply on both sides by 0.02. Okay. So this fraction here will give you 41.25. 330 divided by 8 will give you 41, because this cancels out with that. And then you are only having this, it's 41.25. And bringing this multiplying both sides by 0.02 and also here by 0.02. You'll have 0.02 here equals to only the component 1.02 to the power of n minus 1 divided by 1.02 to the power of n. Okay. So this part here will give us 0.825, and this will cancel out with that, which will give us a 1. Okay. And we will be remaining with minus 1 divided by 1.02 to the power of n. Okay. So now that we only have this n, 1n given here, can make this the subject of the formula. Okay. So it means that we can have 1 divided by 1.02 to the power of n being equals to 1 minus 0.825. Okay. So we know that this is similar to just writing it as 1.02 to the power of negative n. This whole fraction. And then on the right hand side here, we will have 0. Because this is 8, it's going to be 0.175. Okay, so we apply the natural log on both sides. Just take ln of 1.02 to the power negative n equals to ln of 0.175. Yeah. And if we have a power of, we can bring this power onto the left-hand side like that. Okay, so when we bring this negative n here, we will have ln of 1.02 equals to ln of 0.175. So making n the subject of the formula, meaning that the remaining with only n on the left-hand side, we will have negative ln of 0.175 divided by ln of 1.02. Yeah. So we know that n is actually given by n is given by Tm, meaning the year and the compounding period. We have the compounding period, which is m, Tm. Okay, so the compounding period is given to us. So we have to bear in mind that we have to substitute it back onto the equation. So if we substitute this, that, then our Tm is just going to be equals to 12T. So our N is equals to 12T because it is compounded every month. Okay, so maybe let's just substitute it in the equation. So we'll have 12T to be equals to, when you make a calculation of ln of 0.175 divided by ln of 1.02, you will end up with a value of negative minus 88.017. Yeah, 171. Okay. So when we divide both sides by this particular value, so the negative here will cancel out with the negative. when we divide both sides by 12, then we'll end up with 7.3, which will be our years that we are actually looking for. Okay, 7.3 years. Yeah, you can just round it off to one decimal place so that at least you get the value that is needed. So our option number 3 will be the one that is actually given here. Okay. This is where I'll basically end for today. You can review this particular recordings and also note that when you actually explain all of these calculations, it takes quite a lot of time. However, when you sit down and you practice them, because you are not explaining to anyone, then it becomes very quick to actually go through them. Okay. So thank you for the day. That's where I will end. Thank you.